Welcome to DigiDemo and the Internet of Things, second in a series of 2 educational e-learning elements which constitutes a framework for learning activities in the contemporary industrial world. DigiDemo is a project funded by EU through the Erasmus Programme. Participants in the international group are Fachhochschule Vorarlberg from Austria, ESTA Belfort based in France, the Central University UBB Reșița in Romania, and Viken Higher Vocational College based in Norway. The lead applicant and coordinator of the project is University College of Northern Denmark. IoT is short for Internet of Things and is about all the things around us that can be connected to the Internet. This enables us to remotely control the things and collect data in ways that previously was impossible. With IoT, we can enhance products, make work and businesses' processes more efficient, reduce costs and create new digital services. Thus, our products and services increase in quality and the businesses become more profitable. IoT is a central part of Industry 4.0 and boosts the trend towards automation and data exchange in manufacturing. It is also an important tool for sustainability in products and processes. In this video, we present a framework for creating tools for learning IoT and how it can be implemented in products and creating new services. Through IoT, modern manufacturing is highly interconnected, monitored and autonomous. The DigiDemo-Project aims to create tools for interdisciplinary learning of the IoT technologies in an application setting. The first video presents one of the 20 demonstrators developed by the project and how it is used by the students to acquire IoT knowledge. The second video will present a generic demonstrator framework. The DigiDemo framework is a document guiding the description of the demonstrators. Following the documentation for a demonstrator developed according to the framework, it should be possible to build a demonstrator and understand the context it is meant to be used in. In brief, these are educational setups to be used in academic education of mechanical and electrical engineers in order to improve the students' skills in digitalizing products. The target audience of the documents are teachers using demonstrators in their educational environment or developing new ones. The framework document is freely available at the DigiDemo website. The first part of the document gives a description characterizing a demonstrator built according to the framework. The following characteristics apply for the demonstrators. 1. It shall improve teaching. 2. It shall improve sustainability awareness. 3. It shall be replicable. 4. It shall follow industry needs. And 5. It shall be interdisciplinary. 1. The demonstrator shall improve teaching. The rationale of a demonstrator is to strengthen the cross-disciplinary capabilities of students. By using the demonstrator in one or more courses, the learning outcome with respect to digitalization shall be improved. 2. The demonstrator shall improve sustainability awareness. By using the demonstrators, students shall be aware of sustainability issues and get used to include this aspect into design of every system from the very beginning. Sustainability is mainly meant as a sparing use of resources, both raw materials and energy, and good recycling properties. 3. The demonstrator shall be replicable. Any academic institution shall be able to implement its own demonstrator by using the data supplied by the creator of the demonstrator. This shall be feasible with the lowest possible effort, both workload and materials. Hence, the demonstrator material will be open source. 4. The demonstrator shall follow industry needs. One of the main goals for using a demonstrator is to ensure that industry gets highly skilled engineers, able to promote digitalization of products. To ensure this purpose, a demonstrator shall be based on an explicit use case from industry, preferably of an SME, small and medium-sized enterprise, since these companies have higher challenges in incorporating digital elements into their products. In the description of this characteristic, the concrete industrial example shall be given. 5. The demonstrator shall be interdisciplinary. interdisciplinarity is a must in today's product design. Hence, a demonstrator shall improve students' interdisciplinary skills. To address this issue, several elements of the chain of technology dimension shall be covered. In the next part of the document, the key properties of a demonstrator is specified. These are EQF levels for the intended education, year of study, objectives as learning outcomes, the technical domain for the education, and the workload in ECTS for the relevant subject. Further on, the document states classification dimension for the demonstrator. This includes which parts of the value chain the demonstrator is covering, the chain of technology, sustainability justification, the physicality of the demonstrator, the degree of student freedom, the transportability of the demonstrator, the cost and the workload to build it, the size, the weight, and any special request for the product demonstrator. The final part of the document contains an example of demonstrator documented according to the framework. This concludes the introduction to the DigiDemo framework. After you have finished this video, take some time to reflect upon and suggest answers to these questions. 1. According to your experience, are the stated characteristics for the demonstrator sufficient to improve IoT learning? 2. Is the documentation framework suitable for building and implementing demonstrators in your teaching? 3. Do you think the application of one or more demonstrators can improve interdisciplinary learning in your IoT training? The first video in this series shows an example of one demonstrator built according to the DigiDemo framework for pedagogical demonstrators intended for IoT training. Please visit the DigiDemo website to download this framework and documentation for the 20 demonstrators developed by the project. Thank you for watching.